You're listening to EUAudio. Listen, learn, lead. Shape-shifting materials. A lot of effort goes into making the electronic devices we use every day, from the rare earth elements that are mined from the ground to the metal fabrication and assembly work that funds a multi-billion-dollar robotics industry. It's worrying, then, that many of these precious parts end up in landfill at the end of the product's useful life. The UN calls it a tsunami of e-waste, and the World Economic Forum calls it a huge problem. Whatever you call it, every year around 50 million tonnes of electronic waste is generated globally, about the same as 4,500 Eiffel Towers, and it's set to grow to 120 million tonnes unless industry does something about it. Of course, using materials efficiently in the manufacturing process and recycling products at the end of their life are good ways to tackle this problem. But there are limitations to how much of a device can be recycled. Materials are often joined together permanently using adhesives or joining methods that would need to be broken to recover parts that would then be rendered useless. This is where smart materials may offer a lifeline. Technologies such as active disassembly of smart materials uses smart materials including shape memory alloys, shape memory polymers, smart layers, sprays, and engineering polymers. In this process, the materials respond to external stimuli, such as temperature, to change shape, returning to their normal shape once the stimulus is removed. For example, a screw holding together an electronic circuit board could be heated to a specific activation temperature where the screw loses its threads and falls out of its hole. Not only would this allow the screw to be used again once it cools and the threads come back, but it also means that parts could be disassembled much faster, with more of the materials being recovered. In a similar vein, shape memory alloys, metals that change shape when exposed to heat or electricity, may be used to create actuators for industrial use. One company based in Canada has done just that. Kinetics Automation manufactures linear actuators and piston pumps based on shape memory alloys. In doing so, the company has created a product that eliminates the need for a motor and a hydraulic and pneumatic pump, along with all the valves, gauges, filters, hoses, and pipes that go with that. Despite this, the technology delivers just as much force as a conventional actuator with no loss in precision. This breakthrough demonstrates that shape memory materials don't just offer a better way of recycling a product at the end of its useful life, but that manufacturers can create products that use significantly fewer parts in the initial design. As with any new material, design engineers will need to carefully consider the properties of each material and the characteristics of each application before using them. Manufacturing processes may also need to be altered to accommodate these new materials, and consideration given to the fact that, while these materials may be recyclable, there could be a limit to how many times the process can be repeated. EUAudio is brought to you by EU Automation.